Now, in this next example, we're going to look at the equation of the tangents from an external point to a parabola. And obviously the parabola would be in the form x squared is 4ay. Our external point, well, in this case, the external point is given. Its x value and its y value. Our 2 points, and obviously a tangent from an external point, well, there are going to be 2 tangents from an external point that would be tangents to the parabola. Would be 2. What we'll need to do is we'll need to find the values of those parameters of that point. So we'll be hoping to create an equation in P that I will then solve, and hopefully it'll be a quadratic equation, because it will give me the solution to a quadratic equation, gives me the 2 options for P, and the other one I would call Q. So this parameter P would give me 1 point, 2AP, AP squared, and the other value that will initially be called P, but I will interpret it as just a second parameter, would give me my second point, and that could be then called Q, and my point would be 2AQ, AQ squared. Okay, as you can see in this example, the external point 2, 1, there are the 2 possible tangents. We'll have to find 2 parameters, and the 2 points and we'll go on and find. Once we've got the parameters, we can sub into our equation for the tangents to get and show, in this case, that the equation of the tangents are y is equal to x minus 3. That minus 3 should sit over here with that. And the other tangent is negative 1/3 x plus 3. So we can see that one tangent has a negative slope, the other tangent has a positive slope. Now, as you can see, I've written out the full solution, and I've started right at the beginning, right at the very, very beginning. In that I've said that x squared is 12y, 4a is 12, a is equal to 3. My point then becomes P, which is always of the form 2AP, AP squared, would be, subbing the 3 in, 6p and 3p squared. We know that the gradient is always, of the tangent, is the value of the parameter. We found that previously. We can use that. Therefore, the equation of the tangent would be, I'm going to use point gradient. Y minus my y1 is m, which is p, x minus x1. Now, that's the equation of the tangent. But this tangent, we know, passes through the point 2 minus 1. They told us that. So x is 2 and y is minus 1 has to satisfy this equation. So I'm going to put my x and y in there, which will nicely create an equation just in P. So you can see that. I've put y as minus 1 in that spot, and there it is. Minus 3p squared equals p times 2 minus 6p. Here is what I really wanted, an equation in P, that is the parameter. It's a quadratic equation, even better, because it's going to give me 2 values of P, solving a quadratic equation, and which is what I want. I know that there are 2 different parameters. So, tidying up this quadratic equation, gives me 3p squared minus 2p minus 1 is naught. Factorising, solving, I've got my 2 values of p. Once I've got my 2 values of p, I'm going to put them back into here, back to here again, because that's my equation for the tangent. So I've said now sub these values for p into my equation for the tangent, and putting in a third, you might take a bit more time to go through that, and you'll get, I think that's the second equation, and subbing p equals 1 into that same equation gives you the y is equal to x plus 3. You should be fine then to do questions 6 to 8.